Hello everybody and welcome back to Advanced Maths. Today we're looking at the sum of a geometric series. Before we begin, you should be familiar with what a geometric series is. If you haven't watched my first video on geometric series sequences, you should watch that before we continue. You should know that a geometric series starts with u1, and to get to the next term you multiply by r, the common ratio. I have some examples on the screen right now. So every term is found by multiplying the previous term by the common ratio. And as I say, you should be familiar with geometric sequences before we continue with this video. But if you are happy, let's look at a geometric series. A geometric series is where you add up all the terms of a geometric sequence. Or you might call it a geometric sum. The formula we're going to use to calculate the sum of a geometric sequence is Sn equals u1 times r to the power n minus 1 over r minus 1. So let's look at the first example. We've got these geometric sequences here. We're going to find the sum of them. So, look at the first one. The first term is 20, and the ratio is a half. You can find a half by multiplying a term by the previous, dividing a term by the previous term. You can do 10 divided by 20, that will give you half. So the first term is 20, the ratio is a half, and the number of terms we're interested in is 10. We take the formula and we put the numbers into the formula like this. If you type this into your calculator, you get 39.96, etc. And that is the sum of the first 10 terms of this geometric series. Let's look at part B. We've got the first term is 3 and the ratio here is 4. Again, I can find 4 by doing 12 divided by 3. So u1 is 3, r is 4, and n is 10. So the sum of the first n terms is equal to u1 times r to the power n minus 1 over r minus 1. We put those numbers into the equation and we get this, which we can type into our calculator, and we get the answer 104,875. And that is the final answer. That is the sum of the first 10 terms of a geometric series. We can do something interesting with this formula now. We can, for ratios between minus 1 and 1, geometric series converge. And when the power of r gets really big, when n gets really big, r to the power n gets really small. And that's specifically for ratios between minus 1 and 1. In fact, as it goes really, really big, r to the power n gets really, really small, it goes to 0. So if n was to go to infinity, then r to the power n would become r to the power infinity. And for minus 1 is less than r is less than 1, r to the power infinity is equal to 0. So we can make this term in this sequence, in the formula, equal to 0. This simplifies to this, and we can simplify this by multiplying the top and the bottom of this fraction by minus 1. And we would get this. So we get this formula here, S infinity is equal to u1 over 1 minus r, and this is specific to ratios between minus 1 and 1. Let's use this to evaluate some infinite geometric series. First one, we've got the first term is u1, and the ratio is 5 divided by 10, which is 1/2. We substitute these numbers into the equation for the infinite geometric series, and we get this, which we can calculate to be 20 using our calculator. Next, we've got u1 is minus 3, and the ratio is minus 1/3. Substituting that in, we get this. And again, we can type that into our calculator, and we get minus 9 over 4. Be careful there. On the bottom of this fraction, we have a 1 minus -1/3. That is a double negative, and you do have to type in both negatives. There's a negative from the formula, and there's a negative from the fraction. So just be careful there. It's easy to forget one of your negatives and get the wrong answer. The next example, we've got 1, 10, 100, and 1,000. And here the common ratio is 10. And so this doesn't fit the rule or that our sequence must be convergent because the ratio is not between -1 and 1. So the sequence diverges and the infinite sum is just infinity. We have sum of the infinite terms is just infinity. Finally, we've got a sigma notation here. If you're not familiar with sigma notation, I have a video on sigma notation. I will link that below. And we're going to evaluate the sigma sum for the first few terms to get an idea of what the sequence looks like. It looks like this, where I'm just substituting n equals 0, and n equals 1, n equals 2, n equals 3, etc. into the summation. And I can evaluate that like this. 8 minus 2 plus a half minus 1/8. And you should see the ratio here is -1/4, and the first term is 8. So you get S infinity is U1 over 1 minus R is 8 over 1 minus 1/4, which is 32 over 5. And that is the final answer. Okay, I've got some practice questions for you to try yourself. So evaluate these sums, and for the extension question, you can prove that 0.9 recurring is equal to 1. Pause the video now and take your time with this. It will take you maybe about 10 minutes. But when you're ready, you can press play and I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the comments below. Thanks for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. Covering GCSE, A-Level and IB Maths with quick and simple explanations, and new videos are coming soon. Check out advancedmaths.com for more information.